Very good morning, my dear students. Welcome to the channel H2O Chemistry. Today, we are going to learn the topic average atomic mass. It would be very helpful if you learn the terms isotopes, atomic number, mass number before you watch this video. I've posted videos about it. Please go through it so that you will have a better idea. Now, the mass of an atom is very small number. So like the macroscopic particles like this pen, pencil, phone, book, we can measure their masses in the electronic balance or physical balance. But the same method we cannot adopt for atoms because its mass is very small. And there are 118 elements in the periodic table. In the periodic table, all the elements have isotopes. So we need to consider the mass of their isotopes in order to calculate the atomic mass of an element. So if you want to calculate, we need to consider two things. That's why I've written as a problem with that. We cannot take a simple average. So we need to consider two things. What is the first one? Each isotope of an element has its own mass, right? And then there are percentage abundance. There's a very new word. Abundance means availability. So it is a percentage abundance. Availability in the earth crust in percent. So the percentage of abundance is also different. So they have a different mass and also their percentage abundance is different. So we need to consider this in order to calculate this average atomic mass. So before we go to the definition, let us know what is called as average atomic mass. Let's go to the first example. Chlorine has two isotopes, 17 chlorine 35 and 17 chlorine 37. As a students, we know how to calculate the simple average. If I have given two numbers, what you'll do? You add these two numbers, the sum of two numbers divided by total numbers. How many numbers we have? Two numbers we have. So 35 plus 37 divided by 2 is equal to 72 by 2. So the answer is 36. See, if you calculate like this, it will give you a wrong mass of an element. Because, as I said earlier, the percentage abundance of each element is different. Each isotope is different. So we need to consider that. Then only you'll get an perfect average atomic mass. So let us go to the calculation. So in the earth crust, anywhere you go, if you collect 100 chlorine atoms, 75 chlorines out of 100, 75 chlorines will be in the mass of 35. The remaining 25% or 25 numbers will be in the mass of 37. So what you have understood, the availability of or the percentage abundance of this chlorine 35 is 75%, whereas this is 37 is 25%. That's what I said, percentage abundance. So if you calculate by simple average method, this is wrong because we need to consider this percentage as well to calculate the average atomic mass. So what really it says, let's look at this. In order to calculate the AAM, we need to consider the percentage abundance. So what this Out of every 100 chlorines, 75 chlorine atoms are 17 chlorine 35. So that has a mass 35. So its percentage abundance is 75%. Out of 100 chlorines, 25 chlorines are 17 chlorine 37. So its percentage abundance is 25%. Okay, I need to calculate the mass of 100 chlorines. So the mass of 100 chlorines, how will they calculate? The total mass of 100 atoms of chlorine. 75 has a mass of 35. So 75 into 35 plus remaining 25% have a mass of 37. So 25 into 37. 75 plus 25 you get 100. So I need to calculate the mass of total mass of 100 chlorine atoms. So 75 into 35 plus 25 into 37. The answer is, you can see the values. 2625 plus for this 925. If we add these together, we have got 3550. Now this is a total mass of 100 atoms, but I need for only one atom. How will you calculate for one atom? Or else how will you take average? I have 100 particles, so I want to divide it by 100. You divide it, very simple idea is 3550 divided by 100, so that I can get an average mass for one atom. So 35.5, the unit for this is U, that's why I've written, it's called unified atomic mass, we already learned. So 35.5 is the mass of chlorine atom. I hope this is very helpful to you, right? Now come to the definition. The average atomic mass of an element is the weighted average of masses of its naturally occurring isotopes. So the average atomic mass of an element is weighted average of a masses of its naturally occurring isotopes. What is meant by the weighted average? So this is what you have to learn very clearly. I said the direct method how to take, but there is one more method we can do to calculate the average atomic mass. Both are same, but in order to calculate step by step, we are adopting this. What is meant by this weighted average? Sum of the products of fractional abundance of the isotopes and their corresponding masses. Sum of the products of fractional abundance. So far we know what is called percentage abundance. Now it says, so if you multiply the masses and the fractional abundance, after that we need to add that so that we will get the weighted average. So this weighted average is called average atomic mass. So let us go to the sum. Come to this, your book method. Conversion of percentage abundance to fractional abundance. I told you already, the chlorine has two isotopes. 17 chlorine 35 is available 75%. 17 chlorine 37 is 25%. Fractional abundance is equal to percentage abundance divided by 100. So we are cancelling out this percent so that we will get the fractional abundance. So fractional abundance of 17 chlorine 35 is equal to 75 divided by 100 is equal to 0.75. Similarly, Fa, fractional abundance of 17 chlorine 37 is equal to 25 divided by 100 is equal to 0.25. Now, how will you calculate this weighted average? So as we learned, it's a sum of products of fractional abundance and their corresponding masses. So the fractional abundance of 17 chlorine 35 is 0.75. So 0.75 into the mass 35 plus the fractional abundance of 37 mass is 0.25. So 0.25 into 37, you add these two, you will get the value 35.5. So this is another method you can choose to calculate. My dear children, you familiarize these methods, these two methods, it will be very, very helpful. 35.5 U is an average atomic mass of chlorine isotope, not the mass of individual atom of chlorine. Remember, it is an average atomic mass. We have taken an average. So if you weigh a single atom, the weight may be a different one. Got it? Now let us go to the next example in the next video. Thank you.